Department of Physics, St. Joseph's College for Women Autonomous presents St. Joseph's massive open online courses in electronic instrumentation, and this is a skill effective course for undergraduate students. Course Electronic Instrumentation Chapter 2 Oscilloscope. In this Lesson 2.4 Screen for Cathode Ray Tube. Myself, Dr. C.H. Praveen Babu, Assistant Professor, Department of Physics, St. Joseph's College for Women, Autonomous, Visakhapatnam, is the instructor for this course. Lesson 2.4 Screen for Cathode Ray Tube. Learning Outcomes. What is screen for CRT? Which material is used for screen for cathode ray tube? Screen for CRT. The light produced by the screen does not disappear immediately when bombardment by electrons ceases, that is, when the signal becomes zero. The time period for which the trace remains on the screen after the signal becomes zero is known as persistence. The persistence may be as short as few microseconds or as long as tens of seconds or even minutes. Medium persistence traces are mostly used for general purpose applications. Short persistence is needed for extremely high speed phenomena. Long persistence traces are used in the study of transients. Long persistence helps in the study of transients since the trace is still seen on the screen after the transient is disappeared. The screen is coated with fluorescent material called phosphor, which emits electron when bombarded by electrons. There are various phosphorus available which differ in color, persistence, and efficiency. One of the common phosphorus is wilmite, which is zinc orthosilicate with traces of manganese. This produces the familiar greenish trace. Other useful screen materials include compounds of zinc, cadmium, magnesium, and silicon. The kinetic energy of the electron beam is converted into both light and heat energy when it hits the screen. The heat so produced gives rise in phosphor burn, which is damaging and sometimes destructive. This degrades the light output of phosphor and sometimes may cause complete phosphor destruction. Thus, the phosphor must have high burn resistance to avoid accidental damage. These plates deflected the beams when the voltage applied across it. The one pair of plates moved the beam upward and the second pair of plates moved the beam from one side to the other side. The horizontal and vertical movement of the electron are independent of each other, and hence the electron beam is positioned anywhere on the screen. Similarly, the phosphor screen is provided with an aluminum layer called aluminizing the cathode ray tube. This is shown in the image. These aluminizing layers serves three functions: to avoid buildup of charges on the phosphor, which tend to slow down the electrons and limit the brightness. It serves as light scatter. When the beam strikes the phosphor with an aluminized layer, the light emitted back into the tube is reflected back towards the viewer, which increases the brightness. The aluminum layer acts as a heat sink for the phosphor and thus reduces the chances of phosphor burning. Phosphor screen characteristics. Many phosphor materials have different excitation times and colors as well as different phosphorescence times are available. The types P1, P2, P11 or P31 are the short persistence phosphors and are used for general purpose oscilloscopes. Medical oscilloscopes require longer phosphor decay and hence phosphors like P7 and P39 are preferred for such applications. Very slow displays like radar require long persistence phosphors to maintain sufficient flicker-free picture. Such phosphors are P19, P26 and P33. The phosphors P19, P26, P33 have low burn resistance. The phosphors P1, P2, P4, P7, P11 have medium burn resistance, while P15, P31 have high burn resistance. Why P31 is commonly used? Out of these varieties, the material P31 is used commonly for general purpose oscilloscopes due to the following characteristics. It gives color to which human eye response is maximum. It gives short persistence required to avoid multiple image displays. It has high burn resistance to avoid accidental damage. Its illumination level is high. It provides high writing speed. Note: the light output of a fluorescent screen is proportional to the number of bombarding electrons, that is, to the beam current.
The third part of the CRO is the fluorescent screen. The screen is covered from inside with a material that is sensitive to the electrons. When electrons fall on the screen, it gives a bright light in the position where the electrons hit the screen. This appears from the outside as a bright spot. The screen is divided into squares like a graph paper, so we can take our measurements as we will see later in the examples. The scale of the screen is controlled by the Y gain and time base buttons, where the intensity of the spot is controlled by the brightness button.
From this lesson 2.4 Screen for cathode ray tube, what have we learned? Functioning of aluminizing layers, why P31 is commonly used. Phosphor screen characteristics. In this presentation, picture and animated video are taken from the open sources of Google. Thank you for watching this presentation. All the best.